In this video, we'll be talking about degrees of freedom, which is sometimes a difficult concept to understand, but an important one. We'll be talking about calculating degrees of freedom in both dependent and independent t-tests, as well as in the analysis of variance, or ANOVA. So this video will give you some important background information on what this concept means. Finally, we'll talk about a new distribution, the t-distribution, and its corresponding t-table. Pay attention to how this distribution is different from the normal distribution, the z-distribution, that you may remember from our discussion of z-tests. In t-tests, we'll use the t-distribution and t-table instead of our normal distribution and z-table. Let's get started. So when we talk about that n-1, I mentioned that we refer to that n-1 as being the degrees of freedom, which is often abbreviated as DF. What this essentially is it's the number of scores in a sample that are free to vary. How we can think about this is if when we have our scores, when we have our sample, we know our mean. And if we know our mean and we know all of the scores except for one, essentially we can figure out what that one score is. When we think about that, just kind of in theory, when we think about this concept, if we know our mean and we know all of our scores except one, we can figure out that what that last score is. What that means is that essentially those other scores are free to vary, all except for that one in this example. All of those scores can basically be anything except for the last one. Once we've set all of those other scores, then that last score has to be what it's going to be in order to make that mean work out correctly. To give another example, from instance on this slide, we can imagine that we have 7 hats here. So we can imagine that I have 7 hats. If I wanted to wear, if we were having a crazy hat week or something, and I wanted to wear a different hat every single day, I can pick any one of these hats on the first day. And the second day, I have any number of these, any one of these hats, maybe except for that one. And I can keep going throughout the week, and I have my choice of hats until the last day, and then I'm left with just the last hat. All of those hats on days 1 to 6, those can be any hats. Those hats are free to vary. I have my choice of hats. But on that last day, I don't have that freedom anymore. And that last hat is whatever hat is left is the hat that I'm stuck with for that day. That's essentially the idea of degrees of freedom. And again, we'll put this together a little bit more when we have our next lesson. But this is this idea of what's behind this using n-1. It's the idea that we're leaving some room because we're making this estimate, we're leaving some room and we're determining how many of these scores can vary essentially in this formula. And again, if it doesn't quite make sense yet, I'll go over this again, and this might be one thing that it might be more useful to memorize. It can be a little hard to wrap our minds around degrees of freedom at times, but we'll continue to work on this topic. The other thing that I want to just introduce, because we'll be using it in our next lesson, is introducing the idea of the t-distribution and the t-table. So when we used our z-tests, we know that we used our normal distribution. We used our z-table and our z-distribution. Now that we're using t-tests, now we have a t-distribution and a t-table. So we're going to be using a different distribution, a different table. And so this is going to affect the shape of our distribution, which we sometimes talk about in step 2. And particularly this is going to affect step 3. And we're going to have a new table to learn in order to find our cutoff score or scores. For the shape of the t-distribution, there's actually many t-distributions, and they have similar shapes, but the shapes actually vary based on the degrees of freedom that we have in our particular example. What we can see in this particular picture is that the t-distribution looks a little bit like the normal distribution, but if we look at the tails in particular, the tails are a little bit higher. And what that means is that there's more scores in those tails in the t-distribution than there are in our normal distribution or our z-distribution. So there are more extreme scores than in our z-distribution. So this particular distribution, the t-distribution, is not normal because of this little bit of a difference. And because we're no longer using our normal distribution, this shape is different, that's why we have to use a different table. We can't continue to use our z-distribution because those proportions of scores that we focused so much on in talking about z-scores and percents of the normal distribution and focusing on it for our cutoff scores, those proportions are no longer going to hold up with this t-distribution. So now we have a new table. And so again, when we focus on the shape of our distribution, we'll just talk about our shape of the distribution. Instead of saying that it's normal, we'll focus on it as being the t-distribution with n-1 degrees of freedom. So again, if my sample has 10 people in it, I'll use the t-distribution with 9 degrees of freedom, for instance, at 10 minus 1. And so again, we're going to focus on using the t-table, and I'm not going to explain completely how to use it. Again, I'm just introducing this idea here, but the whole point here is that because our shape is different, we need a different table. And so we're going to see, we'll go over more of how to use this table in our next lesson when we're doing this in practice. But what we're going to see is that we're going to have different sections of this table for when we have one-tailed tests or two-tailed tests. And we're going to look at particularly our significance level. We're going to pick one of these significance levels for either one-tailed or two-tailed tests. And we're going to be using our degrees of freedom in order to choose the correct cutoff score. And so there's going to be a new way to do this. And again, we'll look at this in the next lesson as we go through our steps of hypothesis testing. And we'll look at this when we get to step 3 there.